Good afternoon, students. Today we are going to be analyzing the elements comprising the carbonate group, or group 4. Those elements are magnesium, calcium, and barium. So let's go ahead and get started. Okay, so first we're going to start by adding several drops of our magnesium. Then we're going to add the same amount of drops of our calcium. And finally, we're going to add an equal amount of our barium. Next, we're going to add 1 ml of 3 molar ammonium chloride. And we're going to add 2 mL of deionized water. We will then warm this test tube to almost boiling. Okay, now that we have our hot solution, we're going to add 3 molar ammonium carbonate dropwise until it is just basic. See, with the first drop, we already had some precipitate forming. So we're already basic. Now that we are just basic, we're going to add 1 ml excess of the 3 molar ammonium carbonate. Now you can see how much precipitate we have. We're going to let this stand for 5 minutes. Now after 5 minutes, we've let the precipitation complete, and we're going to centrifuge. I have my balance right here. Okay, so our centrifuge has stopped. We have now centrifuged the precipitate down to the bottom of the test tube. We're going to decant the solution into an alternate test tube. This solution will be labeled S14, and it will be saved to analyze for magnesium ions later. The precipitate will be labeled as R14 for residue 14. And with residue 14, we're going to analyze for barium and calcium ions. To begin with, we are going to test for barium ions in our R14. So we're going to wash residue 14, R14, with 1 milliliter of deionized water. We will then discard the washings. So to our residue 14, R14, we are now going to add 5 drops of 6 molar acetic acid. And then we are going to warm the mixture gently to dissolve the carbonates. Okay, after the addition of 6 molar acetic acid and the warming, you can now see that the carbonates have dissolved in solution. To this solution, we are now going to add 5 drops of 3 molar ammonium acetate. We have 3 molar ammonium acetate here. We're going to be adding 5 drops of this. We will then add a little bit of water. Next, we're going to add 3 drops of 1 molar potassium chromate. Three drops of the 1 molar potassium chromate. As you can see, we're starting to get some yellow precipitate. That yellow precipitate is our barium chromate. Now we are going to warm and agitate this mixture. Okay, our solution has been sufficiently warmed and agitated. We're now going to centrifuge this tube with the balance. We will centrifuge this to precipitate out the barium chromate. Okay, at this point, our centrifuge is stopped. As you can see, we precipitated out and centrifuged down the barium chromate. We'll now decant the solution. This solution is solution 15, and we'll label it S15. It will be saved to analyze for calcium ions. Okay, now we're going to take the barium chromate, which is residue 15, and we're going to confirm do a confirmation test of the barium ion. To residue 15, we're going to add 2 or 3 drops of 6 molar HCl. Here's our 6 molar HCl. We've added our 6 molar HCl. We're attempting to dissolve the barium chromate. We're going to dilute to 2 mils with water. We haven't quite dissolved the barium chromate, so we're going to add just one or two more drops of the 6 molar hydrochloric acid. As you can see, the barium chromate has now been dissolved with the 6 molar hydrochloric acid. We're now going to add 3 molar sulfuric acid. And if the barium ion is present, we should get a white precipitate of barium sulfate upon the addition of 3 molar sulfuric acid. You can see we are getting a precipitate, but we will centrifuge to be able to determine what color that precipitate is. Okay, so our centrifuge is stopped. We remove our tube, and we were looking for a white precipitate. As you can see, we have a white precipitate at the bottom of our test tube. That precipitate is barium sulfate, and this confirms the presence of the barium ion. Okay, we're now going to be testing for the presence of the calcium ion. We're going to be taking solution 15, S15, and we're going to be adding 10 drops of 1 molar potassium oxalate. Here's our 1 molar potassium oxalate. We're going to be adding 10 drops of this to S15. As you can see, we already have a precipitate forming. We are now going to add 6 molar ammonia dropwise until the solution is basic. Okay, our solution is now basic. We're now going to let this stand for 10 minutes for the precipitate to form. Okay, at this point, we have a significant precipitate. You can see. We're now going to centrifuge this to check the color of the precipitate. Okay, at this point, the centrifuge is stopped. We'll remove our test tube. As you can see, inside the yellow solution, we have a white precipitate. That white precipitate is calcium oxalate, and it confirms the presence of the calcium ion. Now, for further confirmation of the presence of the calcium ion, we're going to decant the yellow solution. And to our white precipitate of calcium oxalate, we're going to add a few drops of 6 molar hydrochloric acid. Here's our 6 molar hydrochloric acid. And we're going to fill to 1 milliliter with water. At this point, we've added our 6 molar HCl and dissolved our calcium oxalate. So to confirm the presence of calcium ion, we're going to add 1 more drop of the 1 molar potassium oxalate. And we're going to make the solution basic again with 6 molar ammonia to precipitate out the calcium oxalate. All right, we'll check the pH. Need a little bit more ammonia. As you can see, we're back to basic by the addition of the ammonia. And we can see that we're getting a white precipitate back into the solution, and that white precipitate is calcium oxalate. And this confirms the presence of calcium oxalate, this confirms the presence of calcium ion in our solution. Okay, to complete group 4, we are now going to be testing for the presence of magnesium ion. So we have S14, solution 14 from earlier. To S14, we're going to be adding 1 ml of 6 molar ammonia. And after we add the ammonia, we're going to be adding half of a milliliter of 1 molar sodium phosphate. So half a milliliter of this. We will stir this over a period of 5 minutes. But as you can see, a white precipitate of magnesium ammonium phosphate hexahydrate is a preliminary indicator of the presence of magnesium ion. You can see we're already getting some white precipitate. Okay, it's now been 5 minutes. As you can see, we have our precipitate of magnesium ammonium phosphate hexahydrate. That's a confirmation of our magnesium ion. However, to further confirm the test of the magnesium ion, we're going to centrifuge this. Make our balance. We'll centrifuge our precipitate down. Okay, so our centrifuge has stopped. We're going to remove our magnesium ammonium phosphate hexahydrate in our solution. We're going to discard the solution. And we're going to wash the precipitate with just a little bit of water. And we'll discard the wash as well. So we were left with just our precipitate. To this precipitate, we are going to add a couple drops of 6 molar HCl. We have a 6 molar HCl here. We're going to fill up to 1 ml with water. This will dissolve our magnesium precipitate. As you can see, the magnesium precipitate has dissolved. Now to our solution, we're going to make it alkaline with 6 molar. But first, we're going to add 1 drop of magnesium reagent, which is PN bar for short. This is our magnesium reagent. I'll give one attempt at trying to pronounce that, and it is p-nitrobenzene azorescrinol. One drop of this. Now we will be making our solution alkaline with 6 molar sodium hydroxide. I'm going to check the pH. They are indeed alkaline. As you can see, we have some precipitate forming. We will let this stand for 2 or 3 minutes. Okay, it's been a couple of minutes, and you can now see that we have the characteristic blue lake of the magnesium hydroxide. See that blue precipitate? That is further confirmation that magnesium ion was present. Okay, this concludes our group 4 carbonate ion test for the qual scheme. Thank you.